Hello and welcome to the workshop. Today we're going to have a look at tuned circuits, and we're going to discuss something which they call Q, which basically is how selective the tuned circuit is. In other words, if you've got two adjacent channels, you need the tuned circuit to be as selective as possible so it tunes the station you want but rejects the adjacent channel. So basically what we've got here, we've got a ferrite rod and a transistor preamplifier hooked up to a spectrum analyzer so we can see how good it's performing. Now if you look at the spectrum analyzer, you can see a small hump. The higher up that hump is, the more sensitivity you've got, and the narrower the better selectivity. So we want that hump to be as high as possible and as sharp as possible. Now with the tuned circuit we've got here, a ferrite rod is not normally the best thing to use on shortwave. It works great at AM, but on shortwave it's pretty awful, and you'll see what we mean. So at the moment we tuned into what is roughly about 3 megahertz. Now if you look, as I tune up, that hump actually gets flatter and flatter, and it actually starts going down. So by the time we get to like our top frequency, which is roughly about 10 megahertz, there's just nothing there. We're going to pick up loads of stations all at once, if we can pick them up at all. So basically that is just an awful setup. Yeah, it works absolutely awfully. One of the things that alters how sharp the tuning is the impedance. So we're using a transistor at the moment which has got a low impedance, which loads the coil down. And the way to imagine that, if you imagine like a pendulum on a clock, if you like hold the pendulum, it's not going to swing very well. So basically you want something that doesn't hold the pendulum, or load the signal as it were. So we're now going to change the transistor to an FET just to see if that improves things. So we now have our FET hooked up. And if you have a look, the peak is a little sharper, so it's not loading the coil so much, which means that we're going to have more selectivity and pick up the station we want instead of the ones around it. But we have a similar problem. Although it's improved it, if we start to tune up, you see how rapidly that peak flattens. So again, by the time we get to the top end of the band, we're just going to pick up loads and loads of stations all at once, and again it's not going to be very sensitive. So let's try the same experiments again, but this time with an air coil. Now these are used a lot in shortwave because they work better, and you'll see in a minute. What I've done here, I've wound 20 turns around a piece of cardboard tubing. I made the cardboard tubing by wrapping the cardboard around a AA battery. So it's a nice easy thing to make. You can see how I've done it. Drilled a couple of little holes, threaded the coil through the hole and just wrapped it round and threaded the coil back through another hole, and that makes the thing nice and rigid. So we're going to put this coil on and we're going to repeat the two tests. First of all, our first test is going to be with the transistor. So we just get that set up. Right, so if you look now, even with the transistor, which isn't the ideal situation, we've now got a nice, much sharper peak on our tuned circuit. So just changing from a ferrite rod to an air coil has now given us a good bit of selectivity. So if the station we want is at that peak, the adjacent channels either side are going to be a lot weak, and they're not going to interfere with the station we want. So let's tune this up and see what happens. So with this tuning, you can see that the peak is still staying with us. It widens as you go up, but there's still sort of a peak there. So what we're going to do now, we're going to change it to an FET. So this circuit will be pretty good on the bottom end of the shortwave band, but when you get to the top you're going to start getting a lot of stations all merging together. So now let's try with an FET. So with an FET, wow, what a difference. You can now see we have a super sharp peak. That means that the coil's not being loaded, we've got a nice high Q, and we're going to really be able to tune in that station we want and reject the others. And as we tune up, you can see that peak still stays with us. So even right to the top end of our shortwave band, we've still got enough selectivity to actually tune in the station we want and reject the others. So you can see there, beautiful peak. So basically what we've learnt today, if you're going to build the start of a good shortwave radio, you need an air coiled core and you need an FET input stage. There are ways of doing it with transistors, but they're a little more complicated. They need more external components and you probably need a bit more gain, and you need probably a third coil on the coil. So yeah, the idea is to make these as simple as possible. So that's the basis for our shortwave radio, and we can now start with our shortwave construction and shortwave shootout.